So I will have this. After cutting the cone, I have that, and this is now the angle they are looking for. So this is the arc length. Arc length. Sorry, arc length. Arc length. The arc length, the distance around and around, which is equal to the circumference. So that's why I should say arc length equals to the circumference of cone. Okay. So the arc length is given by theta out of 360, then times 2 pi r, which is equal to the circumference c. So I can substitute and say theta. I'll substitute there and I will say theta out of 360 times 2 times 22 out of 7, then times the radius. Now this will be our radius, which is equivalent to the length L. Do you get that? Do you get that very well? Eh? Yes, so times. Now it will be times 10 because our L was given as 10 centimeters. We got it as 10 centimeters using Pythagoras theorem. Then down that is equal to the circumference, which is 37.7. Right. So what we need to do is to find the angle theta. Okay, so we can cancel this and that, like that. So we remain with 44 theta out of 36 times 7, which is 252 equals to 37.7. So can cross multiply. So 44 theta is equal to 37.7 and times 252. Okay. So 37.7 times 252, you get 9,500.4 equals to 44 theta. So from there we can divide by 44. Divide by 44 on both sides. Our theta should be equal to. So what do we get? I'm getting a big angle, which is 215.9 degrees. And what they have? They got 200 and what? 216. So I think they rounded off 216 degrees, which is still the same answer there. So you have to get to know the most important thing. Sometimes what confuses students is this L with R. This L with R. That R is for that. It's equal to the L, but you know this distance here. If this is a cone that is cut out, then this is the slanting part of the cone, which is L. But now the base itself also has got its own what? Its own radius. What? Its own radius R, which is different from this. From that. Okay, so that's with a question about the cone. There are very many questions that you will find in the miscellaneous questions. If you go to miscellaneous after volume, there will be questions there. That's a Frastrum, which we are going to look at. So this is also a Frastrum. I think they like Frastrum because this is a Frastrum, and it's very important we can put an emphasis. They like so much cylinder and the Frastrum. The cylinder and the Frastrum. That's what they like most. So we are going to put more emphasis on that. You can see they are all about Frastrum. So let us go and look at this one. Is a pyramid, but this is almost equivalent to the 3 dimension that we talked about. But still, you can go ahead and work it out. And this is now the net of the pyramid, whereby the pyramid is cut. The pyramid is cut, and each face is separated. This is how it looks like, and you can be asked to find the surface area of only one face. Okay, let us look at and also a ring. You can see a ring, but a ring is just playing around with circle, the area of the bigger circle minus the area of the smaller circle to get to the area of the what? Even for the sphere, the same thing. Okay, so let us look at the frastrum before we look at volumes. Let's look at area. I don't know that we shall finish. We are left with only one lesson next week, and people are going for Christmas. But we shall give you work. We shall give you work, and then you'll be able to do at home as you pull chicken. You don't want to have pull one side. Cynthia, just call me for some chicken one night. So let us look at the frastrum. The frastrum, you should know that it is just a part cut from the frastum. It is just an area that is section of the cone. It is a section of the cone. So a frastrum is just is obtained by chopping part of the cone. Chopping part of the cone. It is a figure in a shape of a bucket or a lampshade as deprecated below. So you have your full cone like this, and then this full cone is cut into 2 parts. So by cutting it here, it forms 2 parts. So it's likely to form one part like this. Can form one part like this. Can see the areas are different, different from this area down. They are different, and you can also form another one, another part like this. Or the other tip that is cut like that. So all these are what we call the frastrum. So it's a frastrum, it's a frastrum. So the shaded, they're saying that the shaded part in figure B shows the portion of the cone which has been cut off. So this one is done, which is cut off. And what remain here? The frastrum, like that. That's I find the area of the frastrum. To find the area, we apply the laws or the properties of enlargement of the cone. So we are going to look at, I don't know whether I looked at enlargement, but I think you did. So that's what we are going to deal with here. The linear scale factor, the area scale factor, the volume scale factor, if you're looking at the volume. But now we are looking at area, so we have to look at the area scale factor from the linear scale factor, such things like that. So let us first look at this. How do we use the properties of enlargement, and we get to know. So let me first draw this diagram here, the way it is, and you're also drawing it, that cone that is inverted. So drawing the cone, I'm drawing the cone members. You know that what I've drawn is the cone. but I suppose I've drawn the cone. So the center is here, put it there. A great bigger one because okay, like that. So that's my cone initially. Now I want to cut off this down up this part here that is down here. So I'll cut it off from here. Cut off this part. So this part is going away. Okay, so now it means that how many cones are there that I've created? I've created 2 cones. There is the bigger one here. You see the bigger one? There's also the smaller one here. So the smaller one is V, A, B. That is the small cone. Small cone. That is the small cone. And then the big cone is V, C, D. That's the big cone. V, C, D. That is the big cone, and this is the small one. But each one of them has got radius. So each one of them has got a radius. So the radius here. First of all, let me consider this height. So I'm talking about the radius at the center. So this one has a radius 1. It is the bigger radius because it is the radius of the bigger cone. So this is R1. And it also has its own height. So if I do this as the ground, it has its own height. H1. That is the height of the bigger cone, and R1 is the radius of the bigger cone. Okay. Now the height of the smaller cone is H2, and the radius of the smaller cone is R what? Is R2. It is R2, like that. So it means that first we have to get, if we remove this part, if we remove the smaller cone here, if we remove the smaller cone, then we have to get the height of this remaining part that remains, which is H. I'll use the two lines like that, which is H. So that is the height of the frastrum. That will be the height of the frastrum. This is the frastrum, remember this one here. That is the frastrum we are talking about. So we have to find its height by subtracting H1 minus H1, H2. But to do this, we have to use the properties of enlargement. So we are going to consider VCD as the image of VAB. Why are they saying that? So they're saying that VCD is the image and VAB is the object after enlargement. So VAB was the object, and then when it was enlarged, it became VCD. So the smaller cone, it was a smaller cone, and then afterwards it was enlarged, it became a bigger cone, VCD. So in most cases, even in physics, if you want to get to the magnification, it is the height of the image over the height of the object, or it is the size of the image over the size of the object. So in that case, we are going to use the linear scale factor for cones VAB and VCD. The linear scale factor. Okay, let us finish. So now here what we are going to do is let us use that property of linear scale factor of enlargement, whereby we say the height of the image over the height of the object. Okay, so the height of the image is h1 because the bigger one was the image. They say that the object was VAB, it was very small, and then it was enlarged to a bigger cone VCD. That means that VCD is the image. So we say the height of the image over the height of the object. We get the linear scale factor. So linear scale factor can be obtained in different ways. You can consider the heights alone, and you set the height of the image, which is h1, which is big, over the height of the object, which is h1, h2. You can get the linear scale factor. Or you can say that linear scale factor, is also equal to the radius of the image, which is R1, divided by the radius of the object, which is R1, R2. Come together. So that's why we are going to equate them, because all of them give us the linear scale factor. So that's why in the book here you have, therefore, it is equal to h1 over h2 is equal to R1 over R2. So they are equal. They are equal to each other because all of them give you the linear scale factor. The linear scale factor. You know the linear scale factor is what? Whereby they have said VAB is the object, and then VCD is the what? Is the image. So even in physics, I've told you, you get the height of the image over the height of the object. So the height of the image is h1 over the height of the object, which is h2. It should give you a linear scale factor. And also the radius of the image, which is R1 over the radius of the object, which is R2, also give you the linear scale factor. So in the end, you have linear scale factor h1 over h2 equal to R1 over R1 over R2. Okay, so now the next thing is what you're going to do is to find the value of h1 and also the value of h2. Okay, when you look here, h1 is equal to h plus h2. H1 is equal to h plus h2. That means that h2 is equal to h1 minus h. So we are going to substitute. We have to make sure that we don't have different h's here. You should have only one h. You can decide to make h1 a subject, you can decide to make h2 a subject, and you express h2 in terms of h1, or you express h1 in terms of h2. So you should not have h1 and h2 in your formula, in your final formula. Your final formula must be having what is given to you. So in this case, if h2, in this case here, you should see that if h2 is given to, if h1 is down, which is given to you, then make sure that you express h2 in terms of h1. Okay, I repeat, if h1 is given to you, make sure that you express h2 in terms of h1. If h1 is down, which is given to you as a value is given here, make sure that you express H2 in terms of H1. So let us see. So from this diagram that is here, we know that H1 equals to H plus H2. So we are going to express H2 in terms of H1. So from there, we have seen that H1 is equal to H plus H2. So that means that from that case, our H2 is equal to H1 minus H. So in new formula of H1 over H2 equals to R1 over R2, then what we are going to do is to change this one and put H1 plus H2. So we shall have H1 over H1 minus H equal to R1 over R2. Why now? Someone, you may be asking, why are we doing this? Why are we doing this? I'm just showing you this because they may not give you H1, they may not give you H, but they can give you one. So you have to find the other. So this is what you keep on using, okay? So what you keep on using. And also sometimes some lengths cannot be given. For example, the radius R1 may not be given, but you have H1 and you have H2. You have H1 and you have H. And you also have R2. So you have to use this and find R1. Okay, so it will be understandable if we look at a question. So from here, we can cross multiply and find the value of H1. So H1 will be equal to R1 into H1 minus H over R2. Like that. That's H1. Okay, so from here, so when we try and if we try and open up the brackets there. Okay, let me see. Okay. Okay, let us make H1 a subject here. Okay, let me cross multiply again. So we shall have H1 R2 equals to R1 to H1 minus H. Not so important this, but you should just know how all this derivation is not so much important, but you must know how to play around with this. This is what is very important. This part here is what is very important. I may emphasize this as it is very important. If you get to know this, then the rest becomes very easy for you. But this other part that we are trying to derive, not so much important. Just trying to show you how you can make one of these a subject. If you can make H1 a subject or H2 a subject, that means that you must express one into the other. So that's what you should know. So here we correct like terms and we shall have H1 R2 minus R1 H1 equal to negative H1. And here we shall factorize out H1 and we shall have R2 minus R1 equal to negative HR1. So if we divide by R2 R1, we get H1 as negative HR1 over R2 minus R1. Okay, I want to finish this so that you can go for history. So when we say let us multiply by negative on both sides, so here we multiply by negative 1, even here multiply by negative 1. So this one will cancel with that, and we shall remain with H over R1. If we multiply by negative, we shall get negative R2. Negative times the negative, we shall get a positive R1. So it means that H1 shall be HR1 into R1 minus R2, like what is there. So what is very important is this, and then you say where H2 is H1 minus R1. That's what is very important to get to know. And then if you keep on substituting, you end up with this at the bottom that you have just derived. Okay, so you are going for history. So what I want you to know at this point, before we next time when we do a question, you know whether you can go through this example which is here by yourselves. It's an example here about the Frastrum. This question here, and they ask if your year is not. You should pray very well that your year is nice. Sorry, such questions like this. But if your year is they bring such a question like this, that's what you have to go through. But it is doable, very doable. If you master everything very well. So they are saying. So they are saying the figure below shows a bucket with a top diameter 28 centimeters, bottom 14 centimeters. The bucket is 10 centimeters deep. So this is the bucket, and they have given you the height is 10 centimeters. The other edge, which is 10 centimeters deep. I've given you this edge here. So they're asking what capacity of the bucket in liters. So this one is about volume. I think you may not be able to do it. That's why they are saying volume of a cone. So we have not looked at volume. Okay, let me see this question. This is AB. The capacity, whenever they talk about capacity, that is volume. So you may not do anything there. And there is another one. The radius of the cone, circumference, that diameter is good through. This is also volume. Okay, so most of the things are about volume. Now, what you have to know is that get time and practice this up to this point here. Up to this point here. Yeah, this is where it's very important. H1 over H2 is equal to R1 over R2, where H2 is equal to this. That's all that you have to know about the surface area of the cone. Then we shall do questions about surface area. I'm going to get questions from another book. This one is very limited with questions. And then we shall look at first one question, then we shall go to the volumes. Okay, history is going on, so I would like to switch you to history. Cynthia, Esther, and Sandra, you can watch this video once again. It's going to be uploaded now by Teacher Isaac. And you can replay and see what has taken place, especially Sandra. I wish you a nice day, a nice week, and may God bless you. Bye. Bye. Sandra, have you heard? Sandra.
Yes, teacher.
Have you heard what teacher has said?
Yes.
That you dodge lessons. Is this true?
Yeah.
That you dodge lessons. Is it true? Do you have any question before we go? Do you have any question? Esther, do you have any question? You joined late, isn't it?
Yes.
So let's Teacher Isaac upload the video and then you are going to see.
Yes.
Isaac is going to upload the video. Esther, do you have any question? Esther?
Yes, teacher.
You have a question?
Yeah. Yes, but it's long.
Go ahead.
I had not understood the last parts of the finding the value.
H1.
Yes, my network
But
had gone off.
Have you understood up to this part?
Yes, just up there.
That's enough. That's enough. You can leave this part here. Just enough. If you have understood this, where H2 is equal to this,
Yes.
That's enough. So what goes on here may not matter most, because if you have values, if you have your values here, you just substitute, you get H2, then you put H2 here, and you also, if you have R1 and R2, you can get RH1. So you don't need to, this one was just a matter of algebra, which they put in the book here. Maybe someone wanted to make his book a bit bigger, but this is the point, h1 over h2, the height of the image over the height of the object equals to the radius of the image over the radius of the object. But h2 is equal to h1 minus h. Or our h, this h here, if you want to find the h is equal to h1 minus h what? h2. Is it okay?
Yes.
Yes. So get to know this. This is what is very important. This one. So when we come back next time, I will start with a question about that. Okay. This one. Hello. Esther. Esther.
Yes, teacher.
Let me tell you people, let
Yes, teacher.
me give you one. Even let me stop the recording. You people should revise, because when you come back with a